All right, let's go through the solutions for last week's practice exam. And in number one, we're given that f of 0 is 3 and f prime of x is this expression here, cosine of the quantity pi x plus x to the fourth plus 6. And in part A, we just got to go through a straightforward problem and find f double prime of -3. All right, so it means we've got to differentiate. And one thing that they're looking for here is proper use of the chain rule. So keep that in mind. So the derivative of cosine is negative sine, so we get negative sine of pi x. And then we have to multiply the derivative of pi x, which is just pi, so we'll multiply that by pi. And then we'll have the plus 4x cubed, and then plus 0, which we won't write. So you get 1 point for basically doing this part correctly and applying the chain rule properly. Now, f double prime of -3 is, you just got to plug in -3 for x. So we get -3 pi in parentheses there. Some of you were sloppy and you plugged in +3 at this point. So your answer was positive 108 instead of negative 108 like it should be, which is a silly little error. And you just got to be careful for that because you're costing yourself points that you definitely shouldn't be losing. Now, in the solution guide, they said that you didn't have to evaluate the trig function to get full credit on this. Normally you do, but on this example you didn't. So you could have stopped right here and gotten full credit. Okay, that we'll go a little further. Sine of integer multiples of pi works out to be 0. So sine of pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, all that works out to be 0. So this part here is 0 times pi is still 0. So f double prime of -3 is going to be just 4 times -3 cubed. -3 cubed is -27, and times 4 is -108. Again, some of you had the correct answer, or almost at the correct answer, but you had a positive 108 because you forgot the fact that you're plugging in a -3 instead of a +3. All right, for part B, we needed to write the equation of the tangent line to y equals f of x quantity squared at x equals 0. Now, with our function f prime that was given up here, you can go through and find out that, or what f of x equals. You can find an antiderivative of each of those terms, and then you could actually find the constant of integration because they gave you f of 0 was 3. I don't recommend you doing that. It takes more work, and they didn't intend for you to do that. So if you did that, some of you did that, and a couple of you were able to pull it off, but most of you who tried it weren't able to pull it off. So I don't recommend doing that. What you should have done is gone through and just started finding the values that you need. Remember, the equation of a tangent line just looks like y equals, f prime of a times the quantity x minus a plus f of a. And our function here is f of x quantity squared. So we just got to find those values. A is 0. So for instance, y of 0 is just going to be f of 0 quantity squared, which is just going to be 3 squared or 9. And that's our f of a part right here. That's what's going to go in for all of this. Now, we just need to find the slope because we know a is 0. So I need to take the derivative. So I need to find y prime. And we can find y prime by just applying the chain rule and moving forward from there. So the outer function is the square function. The derivative of x squared is 2x, or 2 times something, in this case 2 times f of x, times the derivative of the inner function, which is just going to be f prime. And so y prime of 0 is going to be 2 times f of 0 times f prime of 0. Now f of 0, that's just 3. They told us that. F prime of 0, well, they gave us f prime of x. That's cosine of pi times 0. I might need a little more space than that. Plus 0 to the fourth plus 6. Okay? Well, that's just some arithmetic. 2 times 3 is 6. And then here, cosine of 0 is 1. So this becomes 1 plus 6, or 7. So that tells us that we have a slope of 42. And so we have, this is 0, 9, so this is the y-intercept. So we can just go ahead and write the equation as y equals 42x plus 9, or you can write 42 times the quantity x minus 0 plus 9, which some of you did. You don't need to write the x minus 0 part, but if you do, it's not wrong. So you can work from there. For part C, we're given that g of x is f of the square root of the quantity 2x squared plus 7, and we want g prime of 3. Again, you don't need to know f for this, although some of you wanted to work out f. But this works out nicely, excuse me there for that, with the chain rule. So if I do, if I'm taking the derivative, the outer function's derivative is just f prime, which we know, evaluated at the inner function. And then I need to multiply by the derivative of the inner function, so I get the square root as my next inner function. So derivative of the square root of x, or 1/2, I'm sorry, x to the 1/2 will be 1/2 x, the inner stuff, to the negative 1/2. Then in here again is going to be our inner function 2x squared plus 7, and then multiply by the derivative of that inner function 2x squared plus 7, which is just 4x. Now, you have two applications of the chain rule in this, and they want to see both to get this full credit for this problem. So that's something that they're looking for. The last part is just to evaluate this. So we need just g prime of 3. And so I'm going to do some of this work mentally. So if I plug 3 in for x, I square it, I get 9. 2 times 9 is 18. 18 plus 7 is 25. I need the non-negative square root of 25, which is just going to be 5, times. Now over here, you got to remember with this negative 1/2 exponent that term is in the denominator. 2x squared plus 7, as we just saw for when x is 3, is 5. So this is going to be, 25. And then I'm going to take the square root of 25 and put it in the denominator. So I'll get 5. So I get 1 over 2 times 5 from that part. And then 4 times 3 over here. And you can't stop here. There's times when you can leave things unevaluated, but you got to show that you know where you can get f prime of 5 from. So there's still one more thing that you have to do. And so f prime of 5, remember that's cosine of pi times x, so 5x, plus x to the 4th, plus 6. Just double checking my work. And it shouldn't be 5 times x, it should be 5 times pi. There we go. And then 12 and 10, which reduces to 6/5, which you don't have to reduce, so don't bother. Again, they didn't make you evaluate the trig functions here, so you could stop there, and that could be considered the correct answer. But I'm going to take it further here. For cosine of 5 pi, if you remember your unit circle, the cosine function starts off when x equals 0 at 1. And then if you rotate half a circle pi, that's negative 1. Another half circle for 2 pi, that's back to 1. 3 pi, 4 pi, 5 pi is going to be right back over here. And so cosine of 5 pi is negative 1. We end up with negative 1 plus 625 plus 6 in the parentheses times 6/5, which is just 630 times 6/5, which is 756. And I didn't work that out mentally. I'm just remembering the answer. So there was nothing fantastic that happened there. But that's what you get. You didn't have to do all that arithmetic, because if you make a mistake in the arithmetic, then they're going to penalize you. But if you stop at a correct version of the answer, like right here, you can get that credit and not worry about making a calculation error along the way. Last question is, they tell us that h is the inverse of f, and we want to find h prime of 3. I put a video for this up not too long ago and gave some practice problems, and so you should have been well prepared for this if you would have kept up with doing that work. But in the video, I go through and show how we find that derivative, and I'll run through it very fast here, very quickly. If I compose f and f inverse, I get x, and then if I differentiate both sides with respect to x, like this, of course, on this side over here, we're going to end up with just 1. I don't know why I'm being so sloppy. So I'm going to get f prime of f inverse of x, and remember, I'm using the chain rule here, times f inverse prime of x. That's going to equal 1. We're looking for f inverse prime. That's going to be our derivative of our inverse. So f inverse prime of x is 1 over f prime of f inverse of x. So to calculate this, now remember f inverse is really just h. So this over here, this is, did I just lose something here? Okay, this is really just h prime of x, which is going to be 1 over f prime of h of x. So they told us that f of 0 is 3, so that means f inverse of 3 is equal to 0. Because remember, a function and its inverse are just, we switch the x's and the y's, we reverse the order of the coordinates. So that means that h of 3 is equal to 0. Okay, so now if I want h prime of 3, and that's 1 over f prime of h of 3. But I just found out that h of 3 is equal to 0, so this becomes 1 over f prime of 0. And so I just got to go back and remember that they told me what f prime is. And so I don't think I calculated it at 0 yet, so let's just work this out. And if I did, oh well. So it's going to be cosine of pi times 0 plus 0 to the 4th plus 6. Cosine of 0 is 1, plus 6 is 7, so this works out to be 1/7. So for question number 2, we were given this problem stem or prompt, and they tell us that the figure f shows the graph of a continuous function f in the regions a, b, c, D, and E have areas 5, 2, 16, 5, and 6 respectively. That just means that we pair them up in order. So A goes with the first one, 5, B goes with 2, C goes with 16, D is also 5, and E is 6. Now, one thing to be careful with here is they're giving you magnitudes. You have to interpret that B is going to be negative because B lies below the horizontal axis. Same with D and same with E. And so some of you didn't account for that in your work, and that cost you some points. They also tell us that for x between -7 and 9 inclusive, the function g is defined by this g of x is -6 plus the definite integral from -3 to x of f of t dt. And in part A, they want to know, is there some value of x between -3 and 2 such that g of x is equal to 0? So when you're doing a problem like this, the one thing that should come to mind is the fundamental theorem. Unless you're asked about a rate being a certain value, then you might want to think of the mean value theorem. But in this example here, you want to think of the fundamental theorem. I'm sorry, not the fundamental theorem, the intermediate value theorem. Scratch that. Intermediate value theorem. We did this way back when, trying to show that a function equals a certain value. Most of the time, you're going to be using IVT. So when they give you an interval also, then start by checking what's happening at those endpoints to see if those values work before doing something else. Because oftentimes in the AP exam, that's how they set it up. So let's figure out what g of 3, -3 is. I want to see if I can get a positive output for g and a negative output for g, and then I can run the IVT argument. So this is going to be -6 plus the definite integral from -3 to 3 of f of t dt. And since my upper and lower limits are the same, then that integral has to be equal to 0. And -6 plus 0 is -6. So they're trying to test you on one of your integral properties there as well. Of course, -6 is less than 0, so we got that part taken care of. So let's see what's happening with 2. G of 2 is going to be -6 plus the integral from -3 to 2 of f of t dt. Of course, that's just -6. Let's go up here and take a look at the picture from -3 to 2. From -3 to 2, we're looking at the region C, all of this stuff in here. And region C is the third one on the list, and that's going to be that 16 that's sitting there. So this is it's above the horizontal axis, so it's going to be positive. That works out to be 10, which is greater than 0. And of course, we can now make our IVT argument. They didn't require continuity to be mentioned in the solution guide, and I think that's because g is defined in terms of an integral. And I don't think they expect students to make it a continuity argument about a function defined in terms of an integral. So you can just focus on the IVT argument for this one here. So something like, since g of -3 is less than 0, actually, if we do it like we did in class, which is equal to -6, which is less than 0, which is less than g of 2, which is equal to 10, by the intermediate value theorem. Now, a lot of you abbreviated it, intermediate value theorem. I hope that they accept the abbreviation IVT. I can't guarantee it. I would prefer that you wrote the words intermediate value theorem as opposed to writing IVT down. Same for MVT or any other abbreviation that we have. Those abbreviations are, what we use in class, but that doesn't necessarily mean that they would want that on the AP exam. I don't know for sure. If you're running out of time, at least do the abbreviation rather than nothing at all. But I would try to spell it out. Anyways, by IVT, there is a C in the open interval -3, 2, such that G of C is equal to 0. For the next question, we're trying to find the absolute max and the absolute min of G on the closed interval -7, 9. Some of you aren't paying close enough attention to a question like this, and you're answering the wrong question that you're forming in your mind instead of the question that's actually written on the screen. Okay, some of you are giving me a relative or local argument for absolute extrema. It says absolute extrema clearly in the problem. You cannot be giving an argument about local extrema and expect to be right. This has nothing to do with F prime, or G prime in this case, switching from positive to negative or negative to positive. What you need to do is in this example here, since we're dealing with a closed interval, you need to use the closed interval method. Okay, you need to test the values of G at the critical numbers and at the endpoints and see which is the biggest and which is the smallest. And if you don't do that, you're not going to get full credit for this. So now you get 1 point since G of X is this -6 plus the integral from -3 to X of F of T dt. G prime of X, of course, the derivative of -6 is 0. By the fundamental theorem, this works out to be F of X. You get a point for just doing the fundamental theorem in this problem, just like that. Okay. The next thing is to find the critical numbers. So F is never undefined on our interval. They don't actually require you to mention that here, but I would, just to be complete, because we hold ourselves to a higher standard. Now we want to know where F of X is equal to 0. So if I scroll back up to the picture, F of X equals 0 at the endpoints, -7, 9, but also at -5, -3, 2, and 6. At this part, to get the next points, you just have to mention the interior points, but I'll list all of them: -7, -5, -3, 2, 6, and 9. The interior points, again, are the only ones that they give you credit for, because you're going to test the endpoints anyways. And now we need to go ahead and start running the test. It seems like a lot, but you know what? This is a 4-point question. It's certainly worth putting the time in to do it well and getting as many of these points as possible, because they're not that hard to get. So this is G of -7, but the problem is that many of you didn't pay close enough attention to was that the lower limit is greater than the upper limit, and that's not in the usual way, and you should switch them and make the integral the opposite. So switch the addition to subtraction and rewrite it like this. A lot of you didn't, and you ended up the wrong answer for G of -7, and you didn't realize that you were dealing with your absolute minimum happening at that endpoint. If we go up here from -7 to -3, we're talking about two regions. We have region A and we have region B. A is positive because it's above the horizontal axis, and B is negative because it's below. A has an area of 5, B has an area of 2, so the net area between them is going to be a +3. And so if I go back down here and substitute in that +3, then I get -6 minus that +3, which works out to be -9. And now we're just going to go through and work out the rest of these. Some of these we've already done. So when we get to those, we'll exploit that. This one has the same property that we're going to have to switch the upper and lower limits so that the lower limit is smaller than the upper limit, and we can interpret it correctly. And so if I go from -5 to -3, that was region B, and so that's -2. And so this is going to be minus -2, which of course is going to be a +2, so that works out to be -4. G of -3, we already worked out to be -6. We did that earlier. G of 2, we already worked that out to be 10. We did that earlier. We don't have to repeat work that we've already done. We can just use it in this later problem. G of 6, -6 plus the integral from -3 to 6, f of t dt. So this is going to be -6 plus, well, I know I'm going to have the 16 of the -3, the integral from -3 to 2. Let's go back and show you this. So -3 to 6 includes region C, which is 16, and then D, which is this one right here, which is going to be -5 because that's below. So 16 minus 5 is 11. And so, in fact, let's just go put that in as 11. And then that works out to be a +5 there. And then I need, let me see, what else do I need? Just the endpoint G, or 9, G of 9 is what I need. So -6 plus integral from -3 to 9, f of t dt, which is -6. And let's see, I wish I held this stuff in my head better, but we had the 16 minus 5, which gave us 11, and then E is -6, and 11 -6, so 11 minus 6 is 5. And so that works out to be -1. And so at this point here, you just got to look and say the max is this and the min is that. And if you notice that the min is this -9 that we had back over here, and the max is this 10, all you have to do is write that out, and you get the full credit. So the absolute max is G of 2, which equals 10, and the absolute min is G of -7, which is equal to -9. Now be careful here. Some of you tried to answer this with the x coordinate, not the y coordinate. It does not say give the x coordinate for the absolute max and the x coordinate for the absolute min. It says what is the absolute max and what is the absolute min. So it's asking for the y coordinates. And if you don't give those, you're not going to receive full credit. So be careful for that. Some of you made that mistake. Part C has 2 parts, and a lot of you misread or didn't understand how to do the second part. I'm hoping it was just misreading it and we can easily fix by being more careful. But anyway, the first part is just to find this evaluate this indefinite integral, find this antiderivative. And most of us did this one just fine. So antiderivative of 2x is x squared. Antiderivative of 16 is 16x. And then, of course, plus c. That's 1 point of this 3-point question. And if you don't have that plus c, you don't get that point, okay? So it's important that you include your constant of integration. They specifically state in the solutions, no plus c, no points, okay? They say it slightly differently, but you know what I mean. All right, so how do I do the second part? Well, this is the definite integral from -7 to 5 of f of 2x plus 16, not just 2x plus 16. So a lot of you ignored the f, used this x squared plus 16, plugged in the -5 and the -7, and subtracted. Doesn't work, okay? One, it's way too simple of a problem for this. But anyways, even if they did put that down there, give the correct answer. But they didn't, okay? This is them testing to see if you can do a substitution. So you're going to let u equal 2x plus 16, so that du is equal to 2 dx. And then you look and say, I don't have a factor of 2, so I'll solve for dx and get 1/2 du equal to dx. And so then I can start to rewrite this as, now you know me, I put the multiplier outside the integral because I like to, but you don't have to. I will deal with the limits of integration in a moment, okay? And then the integrand is just f of u du. The 2x plus 16 becomes u, because that's what this first line says down here. And the dx, remember, is the half du, so that's where those go. Now, also remember that our limits of integration in the original integral here are x values because of that variable right over there. That tells you that we're dealing with x values. So what we want to do is we want to rewrite this so that over here we have u values in my upper and lower limits of integration. So what I'm going to do is I'm going to take this -7, I'm going to plug it in down over here and calculate what u is when x equals -7. Well, 2 times -7 is -14, plus 16 is going to be a +2. Same thing with the -5. I'm going to plug that in over here. 2 times -5 is -10. -10 plus 16 is 6. And so those are my new upper and lower limits of integration. You get a point for having the correct integral in terms of u, just like this. Now from here, this just requires us to go back and read the graph. So this is going to be 1/2 times whatever the net signed area of f is between 2 and 6. The letter u doesn't matter. It's a dummy variable. So the fact that our original problem was in terms of t, so what? This is u. We can change it to a t. It's no big deal. But we're going from 2 to 6, and from 2 to 6, we're talking about this region here, D, and D was the region that was the 5, and it's below the horizontal axis, so it's -5. So then I plug a -5 in here, and then I'm done. And if I want to do a little bit more of arithmetic to show off the fact that I can actually manipulate fractions correctly, I can, but you don't have to, or you can even divide like that. But that's your answer. It's going to be -5. No, -2.5 or -5 halves. Jeez, oh. Anyways, a lot of you had points available to you that you left off of your paper or your work because you were not paying close enough attention, you're going too fast, or you're not thinking in terms of the concepts. The most important thing to do is to think in terms of the concepts. The concepts guide you in how you do the math and how you can be successful. The other thing to do is just go carefully enough through it to make sure you're doing things accurately and not making silly little mistakes. Make sure you're reading the problems correctly, making sure you're answering the questions completely. Okay, so learn the concepts, understand what the question's asking, and proceed through it. Work at a quick enough pace to see most of the questions, if not all of them, but don't work so fast that you're making errors. So if you start going too fast, I'd rather have you slow down and see fewer questions, but be more accurate than to go see all the questions and be sloppy. Okay, so find that balance between speed and accuracy, and you're going to do well. Go study.